Hey!
היי, שלום לכולם, ברוכים הבאים ל-JavaScript Israel, איבנט של אוגוסט. בואו נעשה את כל זה במכה ואז נדבר. אחלה. אז ברוכים הבאים ל-JavaScript Israel, תקופה מעניינת מאוד, קצת שמח, קצת עצוב. החלק המאוד מאוד שמח זה שיש לנו היום שני מרצים מדהימים, מטורפים, שבאמת ייתנו הרצאות ברמה מאוד מאוד גבוהה. יש את ריין שמפורסם בגלל נוד ובגלל דנו, ואנה שמפורסמת גם בגלל נוד. הם חבר'ה מאוד רציניים שידברו על דרכים חדשות ומעניינות להריץ JavaScript. אז הרווחנו את זה, אנחנו מאוד מקווים לראות אתכם פיזית בחודש הבא, אבל נראה. כמה דברים קצרים קודם כל, לפני שנלך לכיף. אז קודם כל יש לנו CFP, אם מישהו מכם רוצה להעביר הרצאה, אז חשוב לי להגיד שאנחנו קהילה שמאוד מעודדת מרצים חדשים, והרצאות על נושאים חדשים ומעניינים. אם אתם רוצים להעביר הרצאה אבל מפחדים או רוצים שנעבוד איתכם, דברו איתנו, אנחנו נשמח לשבת ולעזור. יש לנו Code of Conduct, אני רוצה להזכיר את זה. ה-Code of Conduct שלנו הוא אמיתי ונאכף. אנחנו לא ככה נרגיש אותו היום, אני מקווה, בכל מקרה, כי האירוע הוא לא אירוע פיזי, אבל מאוד חשוב לנו שהקהילה תהיה מכבדת ומכילה ונחמדה. אני אדלג על החלק של החדשות היום. יש דווקא דברים נחמדים לדבר, אבל יש כאלה הרצאות מעניינות שחבל לי לזרוק דברים כלליים. אני רוצה להגיד תודה לספיקר בדיס. היום יש לנו שני מרצים, נקרא לזה מקצועיים, שכבר מאוד מנוסים בהרצאות, אבל בחודשים רגילים בדרך כלל יש מלא עזרה של חבר'ה מהקהילה שיושבים עם מרצים ועוברים על ההרצאות ועושים ריוויו, ותודה רבה לטרקס שמאפשרים לאירועים האלה בעצם לקרות, משלמים על מספנסרים ועוזרים לקהילה לגדול ולצמוח, אז check them out ותראו מה קורה. אני מזכיר שיש לנו קבוצה בפייסבוק, JavaScript Israel, משם זה הכל מתחיל בעצם. תצטרפו לקבוצה, תשאלו שאלות, מבטיחים להיות נחמדים, מבטיחים שגם אם אתם ג'וניורים או אתם לא מומחים ב-JavaScript, אנחנו בעדכם. ומי שרוצה, אנחנו עושים רפל של רישיונות לוובסטורם ורישיונות לקוקה, אתם ממש מוזמנים להירשם פה, ותוכלו לזכות ברישיון. עוד דברים שאני רוצה להזכיר, בואו נחשוב שנייה ממש בזריזות. אז זה בעצם סוף החודש, חודש עבר היה לנו מיטאפ פיזי, ממש מגניב מי שהגיע, אני לצערי לא הספקתי להגיע, אני מאוד מקווה להגיע למיטאפ הבא. ההרצאות היום יהיו באנגלית, פשוט כי המרצים לא יודעים עברית, הם יכולים לדבר עברית אבל לא בטוח שהם יבינו. זהו נראה לי, אנחנו מוכנים להתחיל, אז ממש כמה שניות, אני אעבור לטאב הנכון, לעבור מהר לטאב השני, ונחשוב איך אני עושה את זה. אנה, yeah, I'm sorry for the Hebrew, everybody meet Anna, she is a very gifted coder I know from Node.js, she is gonna talk about her experience in Mongo and how to write a database shell. So take it, Anna.
Yeah, hi, and thanks for the intro. So I'll start my slides. So I mean, to be fair, this is less like about how to write a database shell per se, but something that I do in the work that I'm doing right now. So, all right, title is Synchronous IO Node.js. So just to give some short overview over who I am. So I'm Anna, pronouns are she, her. I was on the Node.js technical steering committee until about a year ago, when I stopped working on Node.js full-time and instead joined MongoDB. I'm on the developer tools team there. So maintaining CLI and GUI and VS Code extension for MongoDB. And my handle in most places is @ADDALEAX. And I'm also the mom of these two lovely kittens. And during preparation, they jumped into the picture a couple times. Might be that they're happening to appear on my screen again. All right, but let's jump into it. Okay, so let's talk about synchronous I/O in JavaScript. So on the left-hand side, we have this we have the synchronous way to read files in JavaScript, in Node.js at least. So you use fs.readFileSync, you pass the file name, you get the results back as a plain JavaScript buffer or screen. On the right-hand side, the promises way, probably most of you are familiar with both of these, where you use like a fs.promises.read file, which works differently. And while these look very similar, let's just like take a quick reminder of like why we don't want to do synchronous I/O in most cases. By the way, I expected the synchronous version to actually be slightly faster than the asynchronous one, because asynchronous code has to do some extra work. That's true. It has to like schedule doing something and then actually do something and then report back the result. But last time I benchmarked this, after fixing like a performance bug in the promise version, that was actually faster. If you want to take a look at that, feel free to. I don't know why that is the case. But anyway, so what happens in the synchronous case is that, well, everything happens synchronously, which means only one thing can ever happen at a time. You first read users.txt, then you read orders.txt. And there's no way that that can be parallelized. On the right-hand side, you can do a lot of things in parallel. You can schedule one operation and then immediately schedule the next one. And you can wait for both results while they're both happening at the same time. That is the big selling point of Node.js, other than like being able to run JavaScript in a lot of non-browser environments. The big thing is you can do single-threaded parallel I/O. All right. Okay, so quick recap. So I guess you couldn't see these parts, or my cats, but so left-hand side synchronous code, right-hand side asynchronous code. You've all probably seen that in some way at some point. And yeah, so and this is like how these two compare generally. So yeah, but generally you say you don't want to do synchronous I/O for that reason, because it's generally not the most performant thing. There are a couple exceptions when it's like generally fine to do it. Well, I think like there's experimental support in the latest versions of Node for top-level await. But generally, if you want top-level code that loads data, for example, like I don't know, TLS certificates for your server or something like that, it's probably fine to just load things synchronously. There's also the case that you're absolutely sure that it's the right thing to do. And for example, it's you're writing a CLI and you know that at that point where that operation happens, nothing else is happening anyway. Although I would still recommend using async code wherever possible. And the last one is if you absolutely need synchronous code, for example, because you're stuck with an API that requires synchronous code. And this is kind of the case that I'm running into, or ran, or whatever. So this is not like a MongoDB talk at all, but I mean, this is inspired by what I'm doing at work. So if you've ever used MongoDB, you've probably used this Mongo CLI tool where you can pass a URI basically to a server and connect to that, and then run database commands. Like in this case, this db.test.find. If you're using SQL, it's the same as select star from test. And well, if you've ever used it, you might have wondered. So like this is like full JavaScript environment, and in JavaScript things generally happen asynchronously. How is it possible that that you can access this result of .find immediately. Like you could access properties from this array without having to add a wait or anywhere or add a callback anywhere. So yeah. Anyway, what we did, what I did at my year at MongoDB was mostly building a replacement tool. It's called MongoSage, which kind of is supposed to do the same thing in the end, where you can run the same commands and get similar or same output. And unlike the previous Mongo CLI, this MongoSage or Mongosh, however you want to pronounce it, we haven't really settled on anything. But yeah, so it does the same thing, but it's built on Node.js. And so this other thing, this Mongo was a Spider Monkey custom C++ build binary. This is a little different. Generally, it's easier to maintain applications written in JavaScript than those written in C++. It's because we can also build upon a great REPL experience that Node.js provides. And if we're building JavaScript, we can actually do a lot of cool stuff. Like we can embed this in an Electron app. We actually do embed this in the GUI that our team maintains. There's at least the general possibility that we can put this in a web browser and let people interact with databases just straight out of a web page, which, yeah, pretty cool, if you asked me. So, but yeah, that async thing that I mentioned. The legacy shell, old shell, however you want to call it, Mongo, it can just do synchronous execution because it's written in C++. It can do all its I/O in C++, where typically what you do is synchronous I/O, and so that makes things a lot easier if this db.test.find just calls into C++ to do things. But we are actually building on top of Node.js. We're using the Node.js driver, which is the library that you use to connect to MongoDB servers, which, of course, it uses the Node.js networking stack. It's completely asynchronous. And there's a couple of requirements that we have. Like, people generally shouldn't have to know JavaScript to use MongoSage, even though it's like the programming language is if you know the very few pieces that you need to interact with the database, that should be enough. So for example, people shouldn't have to know that async and wait is even a thing. There's a lot of scripts written for the legacy shell that just assume that everything works synchronously. And so that is kind of the situation that we're stuck with. We need to find a way to make this work synchronously. So the first way I already touched on that, everybody knows this, is just to use the synchronous methods wherever it's possible, like fs.readFileSync. That works great, but it doesn't cover a lot of things, including network I/O, which is really important when you're talking about network connections to databases. And also, like, the way that these things are implemented in Node.js is a bit odd because on the one hand, you have all these streams like networking streams or TTY access or generally anything that is not file system and file system stuff. And for example, libuv does not provide a single interface for those different things, which is the I/O library that Node.js uses. So honestly, I feel like there should never have been these fs.sync methods, and instead it should have really just looked like a networking socket or something like that. But yeah, anyway, we have these methods and we can use them if we really want to, but for reasons that I mentioned, this is not really something that works for us, especially because it's not networking IO ready. Okay, the next way. So this was the way that everybody knows. One thing that you probably might not know that you can do is you can actually just write C code for Node.js and compile that to WASM. And WASM is kind of sandbox, but there is a way to break, like a standardized way to break out of the sandbox and access system APIs, which is called WASI. It stands for WebAssembly System Interface. And this is how you would use it generally. So if you've ever written C code, the code on the left might be familiar. It's not super super complex. It's really just reading a file and writing it to standard out character for character. But you can, sorry if you were hearing my cat in the background, but you can load it from JavaScript and you can actually just run it as is once you've compiled it to WASM, which I think is pretty cool. So that is actually a way to do synchronous I/O in Node.js. But also this also has like a couple drawbacks. It is very cool, that's true, but it's I mean, it's still experimental at this point, which is something that makes us not want to do this in production. And it's also not like super useful for writing JavaScript apps, because we would be in the situation that we started with, which is like a C or C++ code base. And that was kind of the point that we wanted to have. Then there's another way to use native code for synchronous I/O. You can write a native add-on. That's not quite fun either. I mean, you can do it. This is also like something that just reads a file line by line and returns a string with its contents. It's not super complex, but we don't really want to do this either. Amongst other reasons, because we're still trying to use the Node.js driver / MongoDB library for talking to the database, for a number of reasons, including that we want to actually provide users with an experience that matches what they do in their applications. So yeah, we don't want to have to implement the Node.js networking stack. We just want to use this pre-existing library that uses the Node.js stack. And so there's one way that's that if you've ever been in this situation, you might have thought about, and that is using workers with atomics. And so the reason that this is like this nuclear warning sign and not the proper atom is that everybody would have just thought I would be talking about React, which this has absolutely nothing to do with. But this is generally something that you can do to make any async operation in Node.js synchronous, which I think that's cool. And again, I've shared a bunch of code. I hope this is large enough to read, even if it's not full screen. But the important parts are the highlighted ones here. So the main thread, it starts a worker and it passes a shared in32 array to that worker. And then it uses this atomics.wait method. And afterwards, it waits to it receives a message that it knows it has received from the worker. This is a Node.js specific extension, this receive message on port thing. But generally, it just means get this message out of the queue for this message port synchronously. In the worker thread, we get that in32 array as under the name notify handle that it was using a shared array buffer. And in that case, we run node fetch on a simple URL. We wait for the text and we send it back over the message channel that the two threads share. And then we do atomics.store and atomics.notify. And this actually wakes up the atomics.wait on the main thread. So, and because the post message definitely has happened before these calls, you can also be sure that this receive message on port thing will actually receive what it's supposed to. So visually, it looks like this. The main thread actually spawns off a worker thread. The worker event loop is the one that does the thing, but the main thread remains blocked in this atomics.wait call. It does not progress execution at all until it gets a notification from the worker that it can proceed. So that is something that you can do. We also kind of decided against that. So this is, I personally think this is very cool. It's great that you can do this in Node.js. You have the full Node.js API available. You have all NPM packages that you want available, because in Node.js, you can just run most things in workers as is without doing any changes. There's still some drawbacks. In particular, this doesn't work on the web because you can't do atomics.wait on main threads. Just doesn't allow that, because otherwise it would be a great foot gun for locking up your rendering process and the whole main UI of your web page. And it's also like super hard to message complex objects back and forth between the worker and the main thread. So none of these things really made us happy with what we want to do. And so I went to my evil scientist lab and I thought about, hey, so what can we do? And so I came up with a way for how this might actually work in a very nice way. So if you don't know, I implemented workers for Node.js, not myself, but a big part of it. And a while ago, I gave a talk about how to do that. And there's this slide from this, which is the general idea of workers is to embed Node.js into itself, just run Node.js on a separate thread, but use the API that a person would also use to embed Node.js into their own application to start new Node.js instances. And so you can actually do that on the same thread. You don't need a separate thread to run a new Node.js instance. So the idea here is to keep the main event loop where it is, but to also allow inner event loops to be created, which you can spin manually, also while the main event loop is still blocked during that time. But this is something that you can actually do. So I built that. And it's available on GitHub. It's not used a ton for reasons that I will get into in a second. But if you think this is something that's interesting for you, take a look at that. This is how you could use it. So you have this synchronous worker class. You can use worker.createRequire to create a require function that creates Node.js modules that work inside this worker, not so that for example, whose networking connections are attached to this worker. And so I can use that to load node fetch. I can just say, hey, please run the event loop for this inner thing until this specific promise is resolved, where the promise is the one for fetching example.org. Then do the same thing with response.text, because you always have this toPromise thing for fetch. And then it prints out the text. And this actually works, and it's just 5 lines of code for running like a fairly complex async operation that uses npm packages that are needed and shipped with Node. But yeah, so it's first of all, it's Node.js only still. We would still ideally want the possibility to embed it in web pages. It's also only working on fairly recent Node.js versions simply because they needed a couple of bug fixes in Node.js to make this work. It's also only implemented as a native add-on. I know there had been some interest after I initially built this to eventually add it to Node.js itself at some point, but it's still super experimental and it's probably really not hard to make it crash your process. But generally, yeah, this fulfills a lot of expectations. Like you have the full Node.js API available, full event loop control. You can interact with JavaScript objects just naturally because they are there. They're in the same address space. You can access them just the way you would always access them. Anyway, this, like I said, this is still something that we wouldn't want to do right now. Also because it works only on very recent Node.js versions. And right, so what is it that we currently actually do? It's very hacky. We kind of just cheat. We have a Babel plugin that we just run on user input and use that to add await expressions where necessary. We mark some calls like this .find call or toArray call here in a way that it returns a promise that has special extra properties. So we can just check, is this, so this extra property basically says, is this something that should act synchronously even though it isn't? And we can check whether that's there. If it is a special promise, we add a wait in front of everything for every single expression inside this inside this input. And it doesn't look exactly like this. This is just to make it a bit more readable. I don't know if it's actually readable. But yeah, so yeah, hacky, but actually it works fairly nicely. So we call that our async rewriter. Just applies await in a bunch of places, or adds these conditional await calls that do this at runtime. We previously had a module that also did this based on static analysis. So try to figure out based on statically what type a call would have and what it would return, and then where to insert await. That was not very flexible because JavaScript is not a language that you can apply static analysis on very easily, at least not for like REPL input. It's very different from like TypeScript code or something. So yeah, this at runtime solution works a lot nicer, and it's not the fastest. That's true. It takes a while to run code, but yeah, that's what we do. Yeah, thank you for listening. The slides are uploaded under this link that I'll probably also share on Twitter. I also am on Facebook, and I know that that's kind of big in the Israel JavaScript community, but honestly, I kind of try to keep that for personal connections only. So Twitter is a little better for that. Yeah, that's it from me.
Awesome. Alon? Just a second. You see me? Oh, right. Great. Hi. So there's like a bunch of questions. I think most of them are from me. Ask away. Yeah, so you actually answered a few of them while we were like during your talk. So first of all, really nice and very cool. Is the rewrite complete? Like, did Mongo already ship the? Did you ship the? Oh, really nice. I had no idea it was like an old Spider-Man thing back then. Cool. So first question: when you were working on worker threads, when you did the implementation, did you consider this use case at all?
I mean, it was definitely touched upon because so V8 exposes this option that browsers set differently for whether to allow atomics that wait on the main thread.
Mm-hmm.
And so we kind of had to make a conscious choice about what we wanted to do, and there was really no reason to forbid it. Mm-hmm. So I guess it was like a possibility that yes, we wanted users to enable to be enabled to do that.
Cool.
I don't think it's like something that we prioritized really, though.
Yeah, I remember all the discussion being about like intensive multi-thread CPU tasks where you had like a shared array buffer. Okay, so cool. It's an interesting application. Another question: if you put it on the worker threads, like one of the things you also touched upon, and I remember a lot of discussions in the issue to refer about, is like if you have V8 has like per like you can't do multi-threaded heaps in V8, right?
Right. Yeah.
And because of that, as you know, you have to serialize and deserialize everything, like structured clone and whatever. Is that like a big limitation if you want to do this sort of synchronous I/O in a different thread, or is that something like would you expect all the data to be binary anyway, or?
So I mean, there's a range of answers to that. So I mean, obviously you can implement something where you only implement the networking I/O on that separate thread and then pass the buffers that were received over the network back and forth. However, that kind of breaks down if you want to use libraries that already that are already built upon the existing Node.js networking stack, because those are going to be working asynchronously anyway.
Yeah.
So that's doable, but hard. One thing that if we were to implement a solution like this, it would probably be more like we run the full library and all the commands inside this worker, and then maybe just pass the inspected results that we print in the REPL back. So only pass strings back and forth. I think that would actually, be reasonable here.
Cool. Last one, I think, for me, and then we have a few others. So Alan, can you hit the thing that moves the question? Is that cool? Is that Babel plugin open source? Like the magic thing that rewrites all the code and adds async in a bunch of places?
Yeah, so actually everything that I work on is open source, which is really nice. So we have a mono repo for MongoSH, and it's part of that. It's called Async Rewriter 2, because Async Rewriter 1 was basically that static analysis version that is not really working out for us in the long run. Yeah, cool. You can take a look at it. It's not like written in a way that is necessarily easily usable out of the box for other applications, but I don't think it would be too hard to adjust.
Cool.
If you really want to do this, which I hope you never have to.
Integrate right now into every code base I can put them. Okay, great. We have a question. Is using workers recommended for async ops if you have many ops?
So it's not recommended if you're doing async IO, which is maybe what you're talking about. Ops is not like very specific. I mean, the typical use case for workers, if you have CPU intensive work that you want to offload from the main thread, that does not typically mean async IO, because Node.js async IO is already very good at parallelizing things. Depends a bit on what you're doing. In any case, benchmark it. That's going to be the best answer you're getting.
Cool. That is just thank you. Ellie asks, are you the one who developed shared memory for multi-threading? If so, then why not use it?
So lots of people have implemented a lot of shared memory implementation for a lot of multi-threading implementation. What I did do was add worker support to Node.js, and that included adding shared array buffer support to Node.js. The same thing had existed for a long time in browsers at that point anyway. Yeah, so I mean, shared memory it's still not super useful if you're only able to share byte arrays like buffers or typed arrays. It's nice, but it doesn't cover everything that you would usually want to see covered. It's kind of the same as like when Benjamin asked if how hard the impact of serialization and deserializing using the methods that browsers and Node.js provide is. It's typically too much work to just do shared memory and then serialize and deserialize that yourself. There are some experimental projects that actually do have a shared heap for Node.js, so actually sharing JavaScript objects. If that's possible, then that's a lot nicer. But as far as I know, none of these things were actively being worked on in the last 2-3 years. So I'm not seeing that happening in the very near future.
Yeah, I think that's all the questions we have, right? Yeah, cool. So very nice talk, Anna. It's very interesting. I'm a bit terrified personally, but I think all the solutions seem very, but it's very interesting. It's a very interesting thing to explore, I think. Yeah, that's just a thank you.
Sure.
It's always like a very cathartic feeling to be able to take like an old patched C++ code base someone wrote and replace it with something modern. So that's very nice. And like, look, worker threads worked out. I remember like the very first few conversations about it, and when it was super experimental, and now it's like used all over. So really cool. All right, awesome. So thank you, Anna, and I hope meeting you in person. And,
Thanks for having me.
having you.
And yeah, see you.
Cheers.